In this video, we will be discussing straight lines. Now, lines are straight, and it always bugs me a little when math books talk about straight lines, because by definition in math, lines are straight. If you have something in math that is not straight, it's not a line. We call those curves. So going forward, I'm dropping the adjective straight because it bugs me. The slope of a line. If x1, y1, and x2, y2 are two distinct points on a non-vertical line L, then the slope m of L is given by m equals delta y divided by delta x, where delta means the change in mathematics, which is equal to y2 minus y1 over x2 minus x1, and that's the same as y1 minus y2 over x1 minus x2. There are four possible types of slopes for lines: positive, zero, negative, and undefined. A line with a positive slope rises from left to right. A line with a zero slope is horizontal. The y values of any 2 points on the line will be the same, and if we subtract the same thing from itself, we get zero. So that's a zero in the numerator. So the slope will be zero. A line with a negative slope falls from left to right, and a line with an undefined slope is vertical. The x values of any two points on the line will be the same, and when we try to calculate the slope, we have a zero denominator. Since we can't divide by zero, the slope is undefined. So for example, we sketch the straight line that passes through the point negative 2, 5 and has a slope of negative 4/3. First, we plot that point negative 2, 5 on a Cartesian coordinate system. Then a slope of negative 4/3 means that we move 3 units to the right for every 4 units down. Technically, it means that we move 4/3 units down for every 1 unit we move right, but it's a lot easier to use whole numbers, and they ultimately mean the same thing. We can figure out in a few more points to plot using this information, whatever the case. So if we take our negative 2, 5 and add to that 3, negative 4, we get 1, 1. If we take 1, 1 and add 3, negative 4, we get 4, negative 3. And we could do the same thing by subtracting 3, negative 4 from negative 2, 5. I just haven't done that here. We plot each of these points on the same Cartesian coordinate system, then sketch the line between them, and this is what we get. Here is that line. This is going from negative 10 to positive 10 on both the x and y axes. So it's a nice, this is pretty true to what the graph would look like. Another example, find the slope m of the line that passes through the points negative 1, 1 and 5, 3. We use the slope formula, m equals y2 minus y1 over x2 minus x1. And I've made my second point x2, y2, and my first point x1, y1. So that's going to give us 3 minus 1 over 5 minus negative 1, which is 2 over 6, or 1/3. Two distinct lines are parallel if and only if their slopes are equal or their slopes are undefined. For example, let L1 be the line that passes through the points negative 2, 9 and 1, 3, and L2 be this line that passes through the points negative 4, 10 and 3, negative 4. And we determine whether these lines are parallel. To determine whether the lines are parallel, we calculate their slopes. Let M1 be the slope of L1 and M2 be the slope of L2. So M1 is 3 minus 9 over 1 minus negative 2, which is negative 6 over 3, or negative 2. M2 is negative 4 minus 10 over 4 minus negative 3 minus negative 4. That's negative 14 over 7, or negative 2. The slopes are equal, the lines are parallel. Equations of horizontal and vertical lines. Since points on a horizontal line have the same y-coordinate, b, the equation of the horizontal line is y equals b. Since points on a vertical line have the same x-coordinate, a, the equation of a vertical line is x equals a. Here's the point slope form of an equation for a line. An equation of the line that has slope m and passes through the point x1, y1 is given by y minus y1 equals m times x minus x1. And this equation is called the point slope equation of a line. So for example, we find an equation of the line that passes through the point 1, 3 and has slope 2. We only need to plug in the proper values into the point slope equation. M is 2, x1 equals 1, and y1 equals 3. So y minus 3 equals 2 times x minus 1. And we simplify this by bringing everything over to the same side and have 2x minus y plus 1 equals 0. We want to find an equation of the line that passes through the points negative 3, 2 and 4, negative 1. First, we're going to find the slope. M equals negative 1 minus 2 over 4 minus negative 3, which is negative 3 over 7 or negative 3/7. And now that we have the slope, we can use either point for x1, y1. We'll use negative 3, 2. That gives us y minus 2 equals negative 3/7 times x minus negative 3, which is negative 3/7 times x plus 3. I'm going to multiply both sides by 7 to get rid of that denominator. That gives me 7y minus 14 equals negative 3 times x plus 3, and then I multiply through to get 7y minus 14 equals negative 3x minus 9. And we bring everything over to the same side, and we get 3x plus 7y minus 5 equals 0. And it's important to note that it doesn't matter which point we used as x1, y1. If we used 4, negative 1, we'd still wind up with the same equation. Y minus negative 1 equals negative 3/7 times x minus 4, and we multiply everything by 7 to get 7y plus 7 equals negative 3 times x minus 4. 7y plus 7 equals negative 3x plus 12. So 3x plus 7y minus 5 equals 0. Same equation we got on the previous page. Same thing. Perpendicular lines. If L1 and L2 are two distinct non-vertical lines that have slopes M1 and M2 respectively, then L1 is perpendicular to L2, written L1, and then this little upside down T, L2, that's the perpendicular sign, if and only if M1 equals negative 1 over M2. So find the equation of a line that passes through the point 3, 1 and is perpendicular to the line with equation y minus 3 equals 2 times x minus 1. So that line that we're asking, is it perpendicular to this, has a slope of 2. So the line that we're looking for has a slope m equals negative 1/2, and it goes through the point 3, 1. So we find an equation for the line. Well, we can start with y minus 1 equals negative 1/2 times x minus 3. That's our point slope form. And then we multiply everything by 2 to get 2y minus 2 equals negative x plus 3. And we bring it all over to one side to get x plus 2y minus 5 equals 0. A straight line L that is neither horizontal nor vertical cuts the x-axis and the y-axis at, say, points A0 and 0B respectively. The numbers A and B are called the x-intercept and y-intercept of L, respectively. An equation of the line that has slope m and intersects the y-axis at the point 0B is given by y equals mx plus b. This equation is called the slope-intercept form of the line. It is generally the most commonly used form of a linear equation. Given any other form of an equation for a line, we can find the unique slope-intercept form equation by solving the equation for y. So for example, find the slope-intercept form of the equation of the line with equation 3x minus 4y minus 8 equals 0. We're going to solve the equation for y. So we can start by subtracting 3x minus 8 from both sides of the equation, giving us negative 4y equals 3x plus 8. That should be negative 3x plus 8. Yeah, I did that wrong. I apologize. My slope is going to be the wrong. My slope is wrong here. So now we need to divide both sides by the coefficient of y, -4, which gives us, this is going to be positive 3/4 x plus minus 2. So from here, if necessary, it's easy to see that the slope of the line is m equals 3/4 and the y-intercept is -2. And I will fix that before I post the slides for you guys to review. The general form of a linear equation, the equation ax plus by plus c equals 0, where a, b, and c are constants and a and b are not both 0, is called the general form of a linear equation in the variables x and y. It's important to note that while our textbook uses this form, many textbooks, in fact, most from what I've seen in 20 plus years of teaching and studying math, use the form ax plus by equals c1 instead, where c1 is equal to -c. And finally, we've got a theorem. An equation of a straight line is a linear equation, and conversely, every linear equation represents a straight line.